In several examples at our travel agency, we found that actors from reality relate to one another in different ways. An example is an attraction that belongs to a category, which in turn may be the category of many attractions. We saw that we can represent these relations, as we design transactions, by including a transaction's attributes in another transaction. We've been told that the agency now works with providers who periodically offer the agency visits to tourist attractions in different parts of the world. Each provider offers numerous tourist attractions, but each attraction is managed by a single provider. To represent this reality, we will create the supplier transaction where we will register providers. We do File, New, Object, name it Supplier, and then add the attributes. Supplier ID as identifier, supplier name to save the name of the provider, and supplier address to save its address. Through the transactions diagram object, we can analyze the relation between suppliers and attractions. We do New, Object of the diagram type, and drag the attraction and supplier transactions from the View folder. We will see that we have not yet established any relation between those two actors. Because a tourist attraction has an only supplier offering it, we will include the supplier identifier in the structure of the attraction transaction. So we open that transaction and add the supplier ID attribute. We also add the supplier name attribute because we will then be able to show the name of the supplier in the screen corresponding to the attractions. We now create a new diagram. Drag both transactions again. And we will see that there is a plain arrow pointing at supplier and a double arrow pointing at attraction. And that tells us that an attraction will have only one supplier and a supplier may offer numerous attractions. In sum, if we add a transaction's identifier attribute to another transaction, which, as we saw, will play a role as foreign key here, a relation of one-to-many, also known as one-to-n, will be established, where the many side of the relation is where the foreign key is located. If we now analyze which tables GeneXus will generate on the basis of that transaction design, we will see that, from the supplier transaction, it will create a supplier table with the same structure as the transaction. And from the structure of the attraction transaction, GeneXus will create an attraction table with the following structure. If we compare the structure of the attraction table against that of the attraction transaction, we will see that the country name, category name, city name, and supplier name attributes are not included in the table because they are attributes inferred, which, as we saw, because they are in the extended table of the attraction table, their value may be recovered from the table where they are stored physically. This is the most common way of representing the relation one-to-many between two actors from reality, that is, between two entities in our system. However, there are other cases of one-to-many relations where we will use another type of representation. Let's recall the case of flights, where a flight has numerous seats and each seat is assigned to a single flight, that is, in a relation of one-to-many. Let's open the structure of the flight transaction to see how we represent that relationship. We will see in this case that seat is like a second level in the flight transaction. So, what is the difference between this one-to-many relation and the relation of one-to-many we saw between attractions and providers? Why don't we represent both cases the same way, with the same transaction design? Note that the existence of seats would have no sense if they were not in a flight. It is senseless to consider a seat without it always relating to the flight it belongs. However, an attraction could not have a provider offering it, and it could still exist on its own as such. The other difference is that when we enter the data of a flight, we're also entering the data relative to the flight seats, just as when we enter an invoice and the lines in it, we will be entering all the information at once. However, the data relative to suppliers and attractions do not necessarily have to be entered at the same time. An entity like seats, whose existence only makes sense when represented in relation to another entity, in this case flights, is called a weak entity. We represent this type of weak one-to-n relation with a single two-level transaction, where the weak entity is in the second level, as opposed to the one-to-n relation between suppliers and attractions, where we created two transactions and in one we set the other's primary key as the foreign key. So far, we've seen relations of one to many, but this is not always the case we must represent from reality. Let's suppose that the reality of the travel agency has changed. Each supplier offers several tourist attractions, as we've seen so far, but each attraction may be administered by different suppliers, instead of just one as we've had. So, the relation between suppliers and attractions is no longer a one-to-many relation, but rather a many-to-many relation. And how should we represent this in GeneXus? The solution is to use two transactions, one for each entity. Also, to one of them we add the other as the second level. This is done upon considering how the data will be entered, either all the tourist attractions for each supplier, or for each attraction all the suppliers that provide it. In this case, the most logical thing to do is to enter the attractions provided by each supplier as we enter the supplier. We will do this in GeneXus. We open the attraction transaction and remove the supplier ID and supplier name attributes and save. We now open the supplier transaction where we add a second level and add the attributes: attraction ID, attraction name, and attraction photo. We will see that the second level remained with the name attraction. We will now see how this relation turned out by creating a new diagram. File, New, Diagram, and drag the attraction and supplier transactions to the diagram. Now there's a double arrow at each end of the relation, indicating that the relation is a many-to-many relation, meaning that one attraction is provided by several suppliers and one supplier provides many attractions. Now let's see the tables that GeneXus will create based on the above design. We see that there is an attraction table, a supplier table, and a table called supplier attraction. We now create a new diagram object and drag the three tables to the diagram. We should note that in this case, GeneXus creates a table for each transaction that is part of the relation of many-to-many, attraction and supplier, and it also creates a third table called supplier attraction to establish the relation. If we analyze the structure of this third table, we will see that the only attributes identifying the other two tables are included. So, every time that GeneXus establishes a relation of many-to-many, that relation will be represented in the database by three tables: one for each entity that is included, and a third one with the identifiers of the other two. We can see that the many-to-many relation between attraction and supplier broke down into two relations of one-to-many, using the supplier attraction table to establish the relation between the previous ones. Lastly, we'll save the changes in GX Server. So, we've seen that we can represent different relations between actors from our reality with transactions and their attributes.